If you've ever tried to connect an AI model to your external tools and databases, you know exactly how it feels. You build the connections, you stretch them to fit, and eventually they violently snap right under the tension. The standard approach to this problem is brute force. Developers write custom integration code for every single service and stuff massive, complex instructions into the system prompt just to force the model to behave. But this friction happens because standard APIs were never actually designed for artificial intelligence. They were built for deterministic programs, software that already knows exactly what data it wants, exactly when it wants it, and exactly how to format the request. Language models operate entirely differently. They process information probabilistically. They often need to evaluate uncertain inputs, ask clarifying questions, and actively explore their environment before deciding what action to take. When bridging these worlds, a central AI node is tied to a calendar, email, and database through a tangled web of custom code. In practice, one minor tool update breaks the connection, sending a cascade of errors back to the model. You are forced to choose. You can spend your time maintaining an unscalable web of fragile glue code, or you can adopt an entirely new architectural blueprint designed specifically for AI agents. This diagram illustrates the differences between traditional APIs on the left and MCP on the right. The biggest divergence is tool discovery. On the API side, you manually define endpoints and deploy system prompts crammed full of rules just to teach the AI one tool. If you do this perfectly, the AI can successfully execute one specific action, like pulling a single calendar event. But chaining multiple tools creates prompt bloat, maxing out the context window until the integration collapses. On the MCP side, you deploy an intermediary server. It automatically advertises available tools and requirements back to the model using a standardized JSON schema. The AI acts as a client. It queries the server in real time to discover what actions it can take, completely bypassing the need for hard-coded instructions. Dynamic discovery gives the model the space to actually reason about which tools to use and what sequence to use them in. Building these server wrappers takes upfront engineering effort, but it completely eliminates the fragility of rigid discovery and bloated system prompts. The next major metric to evaluate is what happens when your underlying AI model updates, or when you decide to swap it for a competitor's model. With traditional APIs, developers write integration code that is deeply tied to one specific model's unique tool use framework. This creates severe vendor lock-in. Moving from one provider to another means tossing out your work and rewriting the entire integration layer. MCP was built as an open standard specifically to solve this, creating universal compatibility across your organization's infrastructure. By placing an MCP server layer in the middle, you decouple the model from the tools below. Because the schema is standard, you can seamlessly swap in any compliant model as a client, while the bottom tool connections remain perfectly stable. It is important to clarify that MCP is not replacing traditional APIs entirely. It functions as an abstraction layer. Your existing REST or GraphQL APIs still operate behind the scenes, but they route through the MCP server, so the language model never has to interact with the messy backend. You add a minor network hop to your architecture, but in exchange, you simplify scaling by hiding all API complexity behind a uniform, model-friendly language. To map your project requirements to the right architectural path, we can look at this decision tree. It starts with one central question: what are you building? If you are building simple scripts or single-purpose applications, the path leads to traditional APIs. Deploying a full MCP server is architectural overkill if your application only needs to hit one straightforward endpoint. A basic Python script built just to pull a daily weather statistic works perfectly fine with a standard API call. But if you are building autonomous, multi-tool agents, the path firmly directs you to adopt MCP. When a system requires chaining actions together, accessing secure enterprise databases, and maintaining dynamic context over a long interaction, this protocol is mandatory. Taking this route eliminates massive amounts of technical debt and cuts down maintenance hours as your application scales. In the same way that HTTP gave the early internet a universal standard for communication, MCP is unifying how AI models talk to their environment. The friction of AI integration isn't the model's fault, it is the architecture's fault. It's time to stop writing fragile glue code and start standardizing your context.